Hello and welcome. So let's solve a few more questions from linear algebra. So let me tell you what we are doing. We are solving previous year question from different paper of GATE. If you are already following me, then you have observed that we have already solved previous 5 year questions from mathematics. Next paper that we are solving is the statistics, and we are targeting one subject of data science and artificial intelligence, that is linear algebra. So whatever the question we are uh, getting from this paper, we are trying to solve those questions, right? So it's a good to do because we don't have the question bank for this paper because this paper is new. So and these questions are very much relevant to the gate, so it's a good idea, or it's a good to solve these kind of questions. So you may, there is a chance that you may get these kinds of question, these types of question in exam also, right? So let's jump onto the question. So today what we will be solving is a statistics paper, and in statistics we have already solved 2023 and 2022. Today we will be solving 2021. Okay, so let's look at the question, and let's try to solve those. And okay, so I have already bring the question here so that I have a space to write. Let me first of all adjust these. Okay, so first let's look at this question number 12. Okay, so question number 12, we have given this matrix A, and we have given this expression, right? You see that this expression is there. Now we have to find the nullity of this given expression, right? So we will have to find the nullity of this expression. And what is nullity? So nullity is the dimension of your null space, not your null space, but the dimension of the matrix that you will get after evaluating this expression, right? So okay, so let's first of all, so you get to know about the nullity. It's the dimension. Then you will have to find the dimension of null space, and that will be your answer. So first of all, let's try to evaluate this expression. So in expression, what are the things that we need to evaluate is the a square and a cube, right? And if you see, look at this matrix A. This matrix A is some permutation of the identity matrix, right? So it's a permutation matrix of identity matrix, because if you see that if you arrange the rows, then some permutation will give you the identity matrix, right? And it's easy to do the multiplication with the identity matrix, right? And even it's easy to do the multiplication with its permutation. Means if any identity matrix uh, or any permutation of the identity matrix, you can easily do the multiplication. So let's first of all do the multiplication. So let's first find out this a square, right? So how you are going to get the a square? The first matrix is 0 0 1 1 0 0, so this is given a, right? And you will have to multiply with itself, right? So 0 1 0, right? So how you do the multiplication? You can go, there are four different way of doing the multiplication, and there are you can think the multiplication in a lot of other way also, right? So one way to think is that you can think like this. What so this matrix is sitting left to this matrix, right? So this matrix will act on the rows of this matrix. So what it will do, how it is going to act on the row? So it will bring the third row of this matrix to the first position. So 0 1 0, and what it will do, it will bring the first row to the second position of this matrix. So the first row will be here, and what this will do, this will bring the second row, that is this one, to the third position. So 1 0 0. So this is a square, right? So this one is a square. Now how you can calculate the aq? So this is your a square, right? And if you a square, you can write a also here. So a is 0 0 1 1 0 0 0 1 0. So you can do the simple multiplication. So what it's going to do, that the second row will be here, and the third row will be here, and the first row will be here. So this is aq, right? So now we have everything, right? Now we can evaluate this expression, that is 5a times iq, sorry, I3, that is the identity matrix A plus A square. So this is nothing but the 5 times 5a, that is the 5 times a. So a we have given that, then 5 times a will be 0 0 5 5 0 0 and 0 5 0, right? And plus 5 times a square, right? 5 times a square. So this matrix is a square, and the 5 times will be the scalar multiplication with the matrix will be 5 0 5 0 0 0 5 and 5 0 0. Now the third is 5 times aq. So this is your aq, then you can simply add, it will be 5 0 0 0 5 0 and 0 0 5, right? Now you can simply add these element by element. So what you are going to get is the 5 5 5 5 5 5 and 5 5 5. Now you will have to find the null space of this matrix. Not exactly the null space, but you will have to find the dimension of the null space, right? So you can easily look at this matrix and you can easily say about the dimension of the null space, right? So what you can do, how you can find, this one is 3 by 3 matrix, right? So how you are going to find the null space, dimension of the null space? One way to let's that first of all calculate the rank of this matrix. So what will be the rank? You can take this, the first element, as the pivot, and you can apply the elimination, and what you are going to get at the first elimination, that is whatever elimination you will apply, the first row will be same, and the second row will be all 0, third row will be all 0, right? So, and you are going to get only one pivot, not more than that. So this is the pivot column, and the rank of this matrix will be equal to 1, right? So not you cannot get more than this pivot, this one, more than one pivot, right? So this is the rank of the matrix, right? So what will be the null space of this matrix? That will be the n minus r, the dimension of the null space, sorry. So the dimension of the null space of, let's say this matrix B. So dimension of the null space of B will be equal to n minus r. So n, that is the number of columns. So we have 3 columns, so 3 minus rank is 1. So what we are going to get is the 2. So the correct answer for this question is 2. So it should not take this much of time, because I am explaining it to you, that is why it is taking that much of time. This is only one number of question, so the weightage of this question is only 1 marks. So you can easily do all these calculation very fast, and you can reach here. Even you can look at this matrix and you can say that there is only one independent column. So the rank of this matrix will be 1, and we will have to find the null dimension of the null space. Then we can say that it is n minus r, that is 2, right? Okay, so we can find also the basis of null space. That is the another thing that okay, now let's jump to the question next question, that is question number 13. So this is question number 13, right? So let me first arrange, make some space. Okay, so this is question number 13, right? We have given, let A be 2 by 2 real matrix having eigenvalue. We have given this eigenvalue, that is 1 and minus 1, and A is 2 by 2 matrix. So we have given 2 eigenvalue, that is perfect. Corresponding to eigenvector, so this 1 belongs to this, for this eigenvalue we have this eigenvector, and for this eigenvalue we have this eigenvector respectively, right? If A is equal to some matrix, then A plus B plus C, the sum of the all elements, what it will be. So this, okay, so this is, you can think this question as so we have given the eigenvalue, eigenvector, so you can write this matrix A as its diagonal form. So you can diagonalize this matrix, right? Because so how, if we have this matrix A, so what will be the diagonal form of this matrix? So how we are going to write this? S, and we will have some diagonal matrix, that is lambda and S inverse. So what is this S? So this S is nothing but the, you put the eigenvector, then this will form the S matrix, right? So it will be root 3 by 2. So this is the S matrix. So if you know how to diagonalize a square matrix, then this question is easy to solve, right? Because whenever you have this power term, whenever you want to calculate the a to the power some infinity terms, then that time this diagonalization of matrix, that will give you this power, right? So that should be your approach, right? So let's first find out this S matrix. So it will be just putting this eigenvector into matrix. So it will be 1 by 2 and root under 3 by 2. So this is S matrix, right? And this S inverse is nothing but the inverse of this matrix. So we can find quickly by using the trick how we can. So it will be plus 1 by 2 and it will be minus 1 by 2, and we will have to also take the determinant. So if we take the determinant here, it will be 3 divided by 4 and plus 1 divided over 4. So 3 divided by 4 plus 1 divided by 4, it will be 1, right? So, and what is this lambda? This lambda is diagonal matrix, and the diagonal elements are the eigenvalues. These are, so this lambda will be, lambda is equals to, you will have to just put the diagonal element as your eigenvalue, and other part will be 0. So this is your diagonal matrix, that is lambda. So now we know everything, that S lambda, S inverse, right? So now you know that if you are doing if you are making a matrix in its, or if you are decomposing your matrix in diagonal form, then it is easy to evaluate the power of square matrix. What I mean by the power of square matrix, that is maybe 2 0 2 0 2 0, something like that, or maybe a to the power infinity. So whenever we have the power, you try to decompose your matrix in diagonal form. If it is a square matrix, then you can, and it will be diagonalizable only when you have the independent eigen vectors, right? So these are the independent eigenvector. So I am very much sure that I can diagonalize this matrix A, and I can write in diagonal form. I can decompose this matrix in diagonal form, right? Now let's evaluate this a to the power 2021, right? So how we are going to get this a to the power 2021? So let's first of all focus on this a to the power a square, right? So can you write this a square, since we know that this a is nothing but this one, right? So how we can write this a square is s lambda s inverse, right? This is a, and we will have to write one more a, that is s lambda s inverse. So this is again a, so this is a square, right? Now you focus this one, a inverse a or s inverse a. What is this? This is nothing but your identity matrix, right? Now this overall expression will look like s lambda, sorry, lambda square s inverse, right? So for a square, what you are getting the result is, you see that your these two matrices are still the same, but what is change you are observing is on this diagonal matrix, right? So if you extend this idea to a to the power q, a to the power q till a to the power, what we have to find is 2021. You can extend this idea and you can easily write what will be the a to the power 2021. What it will be? It will be simply s. S is going to remain same. You can try with this aq, a to the power 4, then s this, and what it will be, it to it lambda for 2021, and this s inverse will be as it is, right? And we know that this lambda, right? We know that the lambda, this diagonal matrix, and if you multiply diagonal matrix to diagonal matrix, you are going to get the diagonal matrix. So what will be the lambda 2021? So you can simply multiply this matrix, right? So this much time you will have to multiply. So what will happen, that it will be 1 to the power 2021 and minus 1 to the power 2021, and 0 is going to remain at the same place. So what you are getting is the same thing, right? Minus 1, because it is or odd, so it will be minus 1. So this is again the lambda, right? So overall point is that a to the power 2021 is equal to itself a. And how you are going to get this a? By simply multiplying these matrices, these, right? So let me first write down all these matrices. So it is root under 3 by 2 minus 1 by 2, 1 by 2, root under 3 by 2, and 1, 0, 0, minus 1, and we have root under 3 by 2, 1 by 2, minus 1 by 2, and root under 3 by 2. So you can do the multiplication easily. So it will be root under 3 by 2, and this will be 1 by 2, and this will be 1 by 2, and this will be minus root under 3 by 2, right? And again this root under 3 by 2 minus 1 by 2, 1 by 2, root under 3 by 2. Now you can do the whole multiplication. It will be 3 by 4 plus 1 by 4, right? This one, and no, here it will be minus, right? Yes. And the second element will be root under 3 by 4 plus root under 3 by 4, and this will be 1 by 4 root under 3 by 4, and plus root under 3 by 4, right? And this will be your space here. and this will be 1 by 4 and minus 3 by 4, right? I hope I haven't made any mistake. So what we have to do, we have to find this a plus b plus c plus d. So you will have to add all these, right? So if you add all these, what you are going to get is so this 1 by 4 will get cancelled, this 3 by 4 will get cancelled, and this is 4 times, right? So ultimately you are going to get 4 times root under 3 by 4, and this 4 will get cancelled, so root under 3, that is 1.73. so your final answer is for this question is, that is question number 13, is 1.73. Okay, now let's move forward, and we have another question, that is question number 46, right? So this question number 46, this is a good question, so you can try this question. Okay, let's try. So we have given A matrix, and we have also given B, and we have given C. So A, B, C we have given, and B 4 by 4 real matrices. So and where A, B, U1, U2 and U3 are 4 by 1 real column vector, right? Let this is the determinant, and determinant of A is equal to 6, determinant of B is equal to 2, and determinant, then we have to find this determinant of A plus B minus determinant of C equals to what, right? So the first point is that okay, so let me first explore this one, determinant of A plus B. Can you answer me this question, that the determinant of A plus B is equal to determinant of A plus determinant of B. Is this correct? So my question is this correct? So you can comment this if it is correct or wrong, right? So anyhow you are going to get if it is correct or wrong for any matrix A, B. If this is correct, then you can let me know how this is correct, and if it is wrong, then you can in that case also let me know how it is wrong, right? So comment this thing, that this one is correct or wrong. Anyhow you are going to get this after solving this question, but you can go through this part and you can let me know. Okay, so now let's focus on to our question. So how we can write this A, B, C, D? So you see that let me first of all write this matrix A. So how you can write this? So you all these A, U1, U2, U3, all these are 4 by 1. That means it has the 4 rows and 1 column. So that is the column vector, right? So this A will be some A1, A2, A3, A4, right? And U1 component, let's take at U11, U12 and U13 and U14, and this U2 will be U21, U22, U23 and U24, right? And this U3 will be U31, U32, U33 and U34. So this is how the A matrix will look like once you read the complete question. So this A matrix is the same, these two things are the same, right? So same way you can write for the B, and you can write also for the C. One point to observe here, that the rows or the column, if I say the column, you see that these columns are here and here and here. These columns are the same. The only change with the column is this column, right, of A, and of B this column. And even if you look at this C has this column that is the summation of this column and this column, right? Okay. So the point is that I will, okay, let me first of all find this A plus B, right? Once we have this A plus B, then we are going to find the determinant of A plus B, right? So let's first write the whole expression for this A plus B. Since I am explaining you, that is why I am doing all this calculation. Otherwise there is nothing, there is no required to do all. You can write the few elements and you can get the idea and you can proceed further, right? So let me first of all write this A plus B. So A plus B, how this A plus B will look like? It will be A1 not, so A plus will be, you see that B has this component here and A has this, so A1 plus B1 plus A2 plus B2 plus A3 plus B3 and A4 plus B4, right? And now next these two row you are going to add, and these two row are same, right? So what you are going to get here is 2 times u1, 2 times u2, 2 times u, sorry, not u1, u1 1, u1 2, because it is the same it is the u1 vector, right? So 2 times u1 3 and 2 times u1 4, and similarly you have this here u2 and here u2, so the A plus in A plus B that will add up, right? And similarly for this one, so you will have this u 2u 2 1 2u 2 3 2u 2 3 and 2u 2 4, and here we have 2u 3 1 2u 3 2 2u 3 3 2u 3 4, right? So this is A plus B. Now what I have to find at this determinant A plus B, right? So to solve this question you need to have the knowledge of the properties of the determinants. If you know the basic properties of the determinant, you can easily solve this question. So the first thing what I am going to apply is that this property, that the determinant of matrix A is equal to the determinant of A transpose. So you can verify this is the correct, right? So what I am going to do, so why I am taking the transpose of this matrix, because I know the linearity property of the determinant. What does it say? That if you have a matrix, not, let's take the determinant of that matrix, right? So let's suppose you are taking the determinant of matrix A1 plus A2 B1 plus B2, and you have here B and C. Now if you see that I have given the vertical line, so I am taking the determinant. So how we can, according to the linearity, so what we can do, we can write this determinant as, so we can apply the linearity on this single row, right? And we can keep the other rows as it is. So what we can do is break down this summation. So we can write this as determinant of A1 B1 B C plus determinant of B1 plus B1 B2 and BC. c, right? So do not get confused that I am taking the determinant, it is not the matrix, right? So you evaluate this left hand side and you evaluate this right hand side, you are going to get the same thing, right? So this is also a one property. These two property has come into my mind while looking at this matrix. Why? Because I am seeing that this column, you see that this column is having some form that is of this, right? So that is why I have got this idea of applying this property, right? Ultimately I have to find the determinant of a plus b, right? And we have given the determinant of a and determinant of b, right? So what I am going to do next is I am going to take the transpose of this matrix. Okay, so let's take the transpose of this matrix, that is a plus b transpose. So what we are going to get is the a1 plus b1 plus a2 plus b2 and a3 plus b3 and a4 plus b4 2 and 3, and here it will be 2. Here will be 2u 3 1, 2u 3 2, 2u 3 1, 3 3, 2u 3 4, right? So this is what we are going to get the transpose, right? Now you see, so one more property that I am going to apply, let me describe that one also. So this is the first one, this is the second one, this is the third property that we are going to use. Let's suppose you have this t times a, t times b, c, d. Then you can take this t out of this first row and you can write, and this is again the determinant, t times determinant of a, b, c, d. So this is this property I'm going to apply this one also, right? So you see that you can break down this using this two, and we can take these two columns, common out of this first row and two common out of this second row, and again two common out of this third column, right? So I am going to apply this property also, right? And I have applied this property. So let's break down. First of all, how you are going to break down. So I am not going to write again the complete thing. So first of all, let's take these two. First of all, let's break down, right? Okay, so if you break down, so here it will be a1 b1 a1 a2 b what I am doing, a3 a4, right? And here you will have the same row, that is 2u11, all this same row and same row, plus since I have applied the linearity on the first row, so it will be b1 b2 b3 b4, and these will be same, so I will get the same here, right? Yes, this is what I am going to get, right? Okay, now you take the, so again you will have this 2 times u11, everything you same, the whole thing same as it is here, right? So you can take these two columns out of all those row, so here it will be 2 cube, and this will be simply u11 u12, and here also you can take the 2q common, and here it will be u11 and u22, And you see that what you will get here, if you observe this A matrix and this one, you are going to get this A. So here it will be determinant of A, and here what you are going to get is the B. So here it will be determinant of B. So what you will get is the 2q times determinant of A plus determinant of B. So it will be 2q, and A plus B is determinant of A given 6, and B is 6 plus 2 is 8. So it will be 8 into 8, that is 64. So determinant of this will be 64. Now what you have to calculate is the determinant of C also, right? So I'm not going to do the whole calculation for this C. You can do that. So if you look at this C, matrix, you see that you will have to observe this column. So u1 is here, u2 is here, and u3 is here, right? So once you write down this C matrix like this, the complete form, then here it will be u2. The first column is the u2, right? Second is the u3, and third is the u1, and the fourth one is the A plus B. So what do I mean to say? This C matrix is nothing but the sum permutation of this matrix, some row permutation. You have permuted the row and you will get this C, right? So let me write down this C also, so that you have the clear idea, right? So I am going to apply one more property here, right? So here if you write this u2, here it will be u2. So here it will be the complete u2 column, here it will be complete u3 column, here it will be complete u1 column, and here we are going to get the A plus B, right? Now take the transpose, right? So if you take the transpose, here it will be u2, here it will be u3, and here it will be u1, and here it will be A plus B. See, so this matrix, that C transpose, is nothing but the permutation of this A plus B transpose, right? And how you are going to get this C transpose from this A plus B transpose? You observe that first of all, what you will have to do, you will have to bring this row to here, so that is one row exchange, and you will have to bring this row to here, that is the second row exchange, and okay, so 3, okay, so 1, okay, so the point is that you will have to do the 3 row exchange. Let me explain you. You see that first of all, what you will do, A plus B is here, right? So you are going to do this row exchange, right? So here you will get this u3, right? And here you will get the A plus B. This is the first row exchange. Now you do the second row exchange, this one. So here you will get the u1, right? And here here you will get the u. Okay, so this is fine, because no, here we have the 2, right? The second one. So if you will have to bring the first one, and here you will get the I'm missing anything. We have, okay, 4 rows. Okay, so here you will get the u2, right? So again, this is the second. Again you will have to do one more row exchange. Why? Because you see that u2 is here, u3 is here, so you will have to again do the row exchange. So 3 times row exchange. So 3 times row exchange, That means you will have to multiply the odd times we have done the odd times row exchange. That means the determinant of this C transpose, determinant of this C transpose will be minus times determinant of this A plus B transpose, right? And we already know that the okay, one more thing I want to mention, that in C we don't have this 2, right? This coefficient 2. Other than that everything is same, right? So we have permuted this one, so what we are going to get is we will not get this 2 to the power q term, right? So if you remove this 2 from here, and now what you will do, you will apply the row transformation. So you will apply the 3 times row transformation. Then at the end what you will get is a determinant of A plus determinant of, sorry, determinant of B. So the determinant of C, what you will get is the minus times of determinant of A plus B, that is 8. So determinant of C transpose, that will be equal to determinant of C. So what you will get is the 8, right? So your final answer will be, the 64 minus, because here minus and minus minus plus 8, so you will get 72. So the correct answer for this is 72. Okay, so I hope this is clear. Okay, this last question that we have, that is question number 30. So you can look at this question and you can get the answer. The answer given in the key is option C, right? So you can also let me know how you can solve this question number 30. Also you can look at this property also, is it correct or wrong? So you can comment down. So you can look at this and this, let me know. Otherwise we have solved the 2021 paper of the statistics. So that is all from my side. Thank you.